Hello and welcome to the Section 4.1 lecture today for Algebra in Part 1. This week we're going to get started with some more advanced equation solving. We're going to start off today with some distribute and solve multi-step equations. So the first thing we want to remember is that inverse operations. The opposite of addition, if we see addition in a problem, we want to subtract. If we see subtraction in a problem, we would like to add to undo that. If we see multiplication, we want to divide. Okay, let's keep it all the same. Let's say division. And if we see division, we want to use multiplication to undo that. All right. And it says here that with equations with two or more steps, we want to apply inverse operations in the reverse order. We kind of started talking about this last week, but we're going to get even more involved today. So when I'm looking at an equation, and we're just going to use the first one as an example. If I knew what x was, and this is kind of how I always approach it. If I knew what x was, I have a couple things a couple strategies I can use to solve, but going with the kind of standard order, if I knew what x was, I would multiply it by 2, then I would add 10, and then I would multiply by 3. So I deal with this, then add the 10 because of the parentheses, and then multiply by 3. And I can do that, or I can undo that. So let me just mark those. So times 2. Plus 10, and times 3. I want to undo those in the reverse order, so I will divide by 3, I will minus 10, and I will divide by 2. So for the first part, if I take both sides and I divide by 3, then I get 2x plus 10 over here because those 3's cancel. And that's going to be what... 10 and 24. So, okay, let's just do it this way. You can't see it, but I'm just checking it with the calculator. That's what I thought, 18. I just wasn't believing it for some reason. Then we can subtract 10. And we'll get 2x is equal to 8. And then we'll divide by 2. For x equals 4. Okay, and that's one way that you can do it. Now, I would say probably a little more commonly when we see these problems, because of what we have to do in other scenarios, is I'll often see students that decide to distribute first. And that's okay. That's totally fine. Because it does simplify the expression a little bit, which is kind of another strategy that we kind of use in problems like these, where we want to simplify the one side of the expression before we really get started solving it. So if I distribute, and I could have done it back here, but I don't feel like doing the problem again, just to get the same answer. So if I distribute first, I have 6 times 4, which is 24. There's an x on that one. And 6 times 1 is 6. This actually makes it a little bit quicker and easier to solve this because, again, if I knew what x was, I would multiply it by 24, and then I would add 6. So now I'm just going to undo that, and when I go to undo that, it's going to be only 2 steps rather than 3 steps that we would have if we did it this other way. But the argument there is that, well, we kind of already did a step. You can take it with, take it how you will. Decide to do what you want to do. Subtract 6. And we get 24x equals 72. And let me just check. That's what I thought on that too. Now we're going to divide by 24, and that ends up being 3. Okay. Now you'll notice that this section is titled Distribute and Solve. But I really don't care which way you decide to do that. Whether you decide to distribute, like we did here, or if you want to undo everything that's happening like we did here. Either way is perfectly fine. But I find myself more often than not distributing first, where I get 2x plus 20 is equal to 60. And then I work from there. I do my solving steps from there. Where I would subtract 20 and get 2x equals 40, and then divide by 2. 4x is equal to 20. And this becomes the standard way, or really the only way that works if we have multiple instances of distributing to solve. Okay, and we'll probably see some of those a little bit later. So keep an eye out. So we'll continue with that process. We'll go ahead and distribute first. 4 times 3 is 12x. 4 times 2 is 8. And that equals 68. Now again, what's happening to x? It's being multiplied by 12, and then then added to 8. So undo those in the reverse order. We'll subtract 8. Get 12x is equal to 60. And then we'll divide by 12. 4x is equal to 5. And again, you can always kind of go back and think if your answer makes sense. Some classes require you to write it out. I typically don't. I just say, you should think about every one of them. 5 times 3 is 15. 15 plus 2 is 17. And then you have to determine if 4 times 17 is 68. Just to take a quick look, 4 times 7 is 28. 4 plus 2 is 68. So it ends up working out. Okay, let's go ahead and distribute here. I'm actually going to switch colors. 9 times 2 is 18. 9 times 3 is 27, and there's an x there, and we get 45. We'll subtract the number, move the number to the other side, and we have 27x is equal to, gosh, that might be 27. I think so. Yeah. Divide by 27 on both sides. Long story short, we get x is equal to 1. Okay, last one for this side. We're going to distribute. I don't know why I wrote an 8 again. I don't need that. 8 times 4 is 32, plus 8x is equal to 64. From there, I subtract. Let's go ahead and subtract 32, not 22. And we get 8x is equal to 32. When we divide by 8, we get x is equal to 4. Let's roll right through to the next page. So these would be ones where I would say you could, well, if there's any time that we have multiple x's involved, you have to simplify your variable side, really simplify both sides. But a lot of these other sides are kind of boring because they're just a number. I want to do all my work to make one side look like something times x plus or minus something else equals some number. That's what I want to get to, okay? And there could be division in there. I'm not saying that there couldn't, but I want to do all my work on one side to make one side look like it just has two terms. Okay, an x term or a variable term and a number term. So let's go ahead and do that. I'm going to distribute a negative 5 into these parentheses. I have a negative 2n out in front. I'm going to leave that there for now. Negative 5 times negative 4 is negative 20. Sorry, negative 5 times 4 is negative 20. Negative 5 times 3 is negative 15n. And that equals negative 54. Okay, now combine like terms. So I've got a negative 2n and a negative 15n. I have a lot of negatives in this problem. But when I put those two n terms together, I'll have negative 17n minus 20 is equal to negative 54. Now I want to move the 20 to the other side. I'm going to get rid of it on this side by adding it to make it 0. And then since I did that on that side, I have to do it on the other. We have negative 17n equal to negative 34. And when I divide by negative 17, I get n is equal to 2. Let's see how many we have. Okay. Same process on the next one. Distribute first. Negative 20m. Let's go minus 10. When I distribute that negative 5. Then I have the plus 5, and that equals 95. And there would be another interesting way to do this problem, but I feel like it's more work. Okay, any other ways to solve a lot of these is going to end up in more work. All right, so let's go ahead and combine like terms. I got negative 10 and positive 5. So minus 5 equals 95. And when I add 5 to both sides to get rid of it on the left, it's going to give me negative 20m equals 100. And I want to divide both sides by negative 20. So m is equal to negative 5. Next one we want to distribute first. I've got a negative 4 times positive 1. Got a negative 4 times a positive 4. And then I have another negative x. And again, we have a problem with a bunch of negatives. That's okay. I've got two like terms there. I'm going to go ahead and, okay, that's a 4. Ugly 4, but okay. I'm going to go ahead and put those together as negative 17x, and that equals a negative 72. Add 4 to both sides. Negative 17x is equal to negative 68. And we'll divide by negative 17. And I feel like I've done this, but I'm just going to check. 68 divided by 17 is 4. And since they're both negative, my answer is positive. And there we go. Go ahead and pause the video and give these next 3 problems a shot. Hopefully I had a chance to do that. Let's go ahead and get started. I do like the practice that we're getting a lot of distributing a negative. So I hope you notice that. Negative 2 times 5 is negative 10. Negative 2 times 5m is negative 10m. We have like terms in our m's. Negative 62. Let's call that a negative 13m. And a negative 10. We'll add 10 to both sides. Negative 52 equals negative 13m. And if I divide by negative 13 on both sides, I should get m is equal to 4. Okay, I'm going to go a little different strategy on this one, just to show you that there is another way, but it's a little bit more work. I'm going to treat this whole set of parentheses, and I can do it on this problem. There's only a couple problems that I've seen that you could do this, but just see if you like it. So the thing about this problem is that outside of the parentheses, I do not have any more variables. Okay, so that's the important thing. And what I'm going to do to start is I'm going to treat this whole thing like it's just one variable. The whole set of parentheses, I'm going to kind of look at that as just like an x. I am going to write it every time, but I'm going to treat it like it's a variable. I'm going to solve for that first and see what happens. And kind of see if you get the same answer. I'll probably check it the other way also, but just to show you that it works. I'll add 5 to both sides. And I get 4 times what I'm treating as a variable. My 5's cancel, and that's going to give me, brain's not working too well, 76, negative 76. Divide by 4. Okay, I don't need parentheses anymore. But now I've efficiently solved for the variable, the set of parentheses. Okay, but let me check. 76 divided by 4 is 19, so this is negative 19. And then I'll add 1. I guess this one probably didn't work out too well. I think it was supposed to, but something bad happens right here. Yeah, that's okay. We get negative 18 here. And when we divide by 5, we really get negative 18 over 5. Now, if we cared about what that was, it's negative 3.6. Okay. Let me go back and do it the kind of standard way. But I'm going to take all this. I'm just going to keep it for safe keepings right now. Thought I could shake it to group it, but I can't. So I'm just going to keep it over here so we see it. But I'm going to do it probably the way that you would have done it. I'm going to distribute, and I get 20r minus 4 minus 5 equals negative 89. Okay, I'm a little concerned. It doesn't look like, boy, what did I mess up there? That's going to bug me. Oh, I know what I messed up. Okay, sorry, this was negative 84. I hate it when I do that. I was thinking the wrong way. And then if I were to divide that by 4, this would be a negative 21. So it did work out the way I wanted it to, where that's a negative 20. And that's going to be a negative 4. So we should get a negative 4. If you got negative 3.6, you kind of did like me and made a little boo-boo. But that's okay. All right, let me get back to this. I get 20r minus 9 equals negative 89. I'm going to add 9 to both sides. This is where I realized that there had to be a mistake somewhere because the strategy was sound. It was my calculation of negative 89 plus 5. Somehow I added like way too many. So I get negative 80 there. And divide by 20. Divide by 20. We get r is equal to 4. Negative 4. So you can see mistakes do happen, even with people that are, I don't know, claim it as their profession. It's okay. Just fix your mistakes and learn from them. So this one I'll stay pretty traditional. We'll do the normal method here. negative 3x minus 10x minus 20 equals negative 59. Combine my x's, get negative 13x minus 20 equals negative 59. Add 20. Negative 13x equals negative 39. And if we divide by negative 13, we get x equals 3. Okay? So, that being said, sorry for the mistake. We got it fixed up, though. Make sure that you put any questions you have over on the left. And other than that, have a great day, and we will see you in class.